Hi everyone. Today we are going to have a look at the LeetCode question number 15, a three-sum problem. In the question, we are given an array nums and we need to return three integers I, j and k such that their sum is equal to 0. A condition we are given is that these should be unique. For example, -1, 0, 1 is same as -1, 1, 0, and hence we can return only one of these two and not both. In the example given, we have an array and the answers are -1, -1, 2 as these form 0, and similarly -1, 0, 1 as the sum of these is also 0. If no three numbers are able to sum up to 0, we return an empty array. So the crux of the problem is we need to find three numbers a, b and c that are 0. Now taking an example of a case where we have our nums as -2, 1, 0, 1, -2, 0, 2. The most brute force approach that comes to our mind is we first take a as -2, then check the rest of the array for b and c. The second element as a, check the rest of the array for b and c, and the third element as a, checking rest of the arrays b and c. Now the problem here arises is when a is set as the first element, -2, we see that 0 and 2 make up a pair. Similarly, we would find for 1, 0, 1, then when we would reach -2 again, the answers would be 0 and 2. So this forms a duplicate pair. And the question strictly says we cannot return duplicate triplets. Now when it comes to duplicity, the two most common approaches are either sorting the array or sets. So here we would be sorting this array. We get -2, -2, 0, 0, 1, 1 and 2. So we can set our A for the first element, search for B and C in the rest of the array, then increment our A, and while incrementing, we can check if A was same as the previous one, we can skip it moving on to the next. This removes some aspect of duplicity. Now, this brute force approach of first setting A, takes a time complexity of O of n cube as it has three nested loops, first setting A, then for B and C we would have to set B, search through C from the rest of the array, increment B for the same A, search through rest of the array, and keep on going like this. And a O of n cube time complexity is really bad for an algorithm. So to improve the time complexity, we would be using an approach which we had used during the two-sum problem, where we needed to find two numbers that summed up to a particular target. We can write our target as a is -b plus c. So for a fixed a, we need to find b plus c, which form the negative of our target. This can be done using the two-pointer approach. We fix our a, we then have a left pointer and a right pointer in the remaining part of the array. We calculate the sum. If the sum is greater than 0, we decrease our right pointer. If the sum is less than 0, we increment our left pointer. This works because the array is sorted in an increasing order. So decreasing the right pointer would always decrease the sum, and increasing the left pointer would always increase the sum. While incrementing or decrementing our pointers, we check for duplicity. This improves the algorithm. Having a look at the code, we are given an integer nums. We sort it. We create a result array list. We start a loop from I0 till the end of the array. So this is basically the loop for A. Now one important thing here is this condition, that if num0 is greater than 0, we break. In a sorted array, if the first element is not 0 or negative, there is no chance that the sum can be 0. And hence, we return back immediately. Now one thing to keep in mind here is the condition to check would be nums0 should be greater than 0 and not greater or equal to 0. If the array has 3 zeros, that too makes a valid solution. So we need to check for greater than 0 always. The condition of skipping duplicates for A, that if the nums I is same as the previous one, we skip forward. To make sure the code doesn't give an out of bound errors at the 0th index, so we put up I greater than 0. Now we set a left pointer to the next element to I, a right pointer to the last element. And while left is always less than right, we calculate the sum of the three numbers. If the sum is greater, we reduce the right pointer, reducing the sum. If the sum is less than 0, we increase the left pointer, increasing the sum. And else, if the sum is 0, we add these three numbers as a list in the result array list. We increment the left, we increment the right, and now we check if our left is equal to the previous left, we again increment it to avoid duplicity. And if our right is equal to the previous right, we decrement right once again to avoid duplicity. We go through this again and again till our I reaches the end of the array. And by now we would be having all valid pairs in our result array list. And at the end, we return back a result array list. The time complexity for this is O of n square. Sorting basically takes O of n log n time, and this loops takes O of n square. The I loop runs through the entire array, and for each ith iteration, the two pointers run through the remaining array, thus creating O of n square. And O n log n plus O of n square gives us a time complexity of O of n square. The space complexity is O of 1 or O of n depending on the sorting array method we use. I hope I was able to explain the problem clearly. If you have any doubts or any feedback, comment down. Thank you.